So I think we stopped in the where we stop about the function, what was the function or not, right? Tamam. Then after that one we start talking about here, which example? I remember I gave you that one, floor. I say it's important for computer science and of course engineering. Then we stopped here, we say this is nothing, just we are going to add two functions together. So we are going to combine, say that one plus that one, nothing else. Understood? Good. So here we are, we are going to talk about one-to-one function. The one-to-one function is very important and we are going to use it in the inverse. What do you mean by one-to-one function? In one-to-one function means that for each x, and we say generally if x is not equal to x2, then fx1 not equal to fx2. Or some book is right, y not equal to x, then fx not equal to fy. Understood? Means that if we took two different elements, then the images are different on the y-axis. Understand? Okay, this is the definition. Look at here, you can see we have if for a, b, xy, x1, x2 not equal, then the pictures are not equal. Or for a and b, for all, طبعا, for a and b, if a equal to fb, then a equal to b. So this is p implies q. How about that one? Negation q implies negation p. Understood? So both definitions are true, they are the same, they are tautology, they are, equivalent, not tautology. They are equivalent. Here we have two types of the definition. One of them is discrete. For example, f of a, f of b, like that. And the other we have f of x, x squared. So that one is a continuous, right? Like a calculus one. And we have a discrete like a fa equal to 2, fb. This is the discrete example. So here, both of them, they are important. Listen to me. This is the discrete example. We have what? From a to that one. I have a function. I have a function from a, that one, to b, that one. F of what? F of a equal to 4. Now I'm going to write f of a equal to 4. Okay. Then f of b equal to 5. F of c equal to 1. F of d equal to 3. So if I have a, b, c, d, you can see a, b, c, d. F of a equal to 4, I think. F of b, it was what? 5, 1, 3.
Minus.
No minus. 5, 1, 3. Then of course we have 2 here. We leave the 2 here, right? Because the other said it was 1, 2, 3, 4, 5. So if I ask this function is one-to-one or not, yes, I say one-to-one. Why? Because if I take any different element here, the images are what? Are different. F of a not equal to f of b, not c, not d. Am I right? As well, f of b not equal to a, c, d, and go on. So because each sign from the x-axis, we have a different sign on the y-axis. That's why we say it's a one-to-one function. Do you have any question about this, dears? Clear, right? And easy. Now, we have what? We have a, if is a one-to-one, yes, it's a one-to-one, and we solve it. Okay, later we are going to look at, see here, look at this figure. You can see is one-to-one. Each one has 1. Maybe you ask me, how about that one? Why we leave it? If we left element in the other side, in the b side, what shall we call this function? Later we are going to talk about that one, okay? For now, we have a one-to-one and everything is clear. Good. Now I'm going to the continuous example, like what? Like f of x is equal to x squared. But in this example, it's not like a calculus one. You should be careful, Kaka, that the domain is what? Range is what? Listen to it. Integers, set of integers, 1 to 1. So we have a function from the set of integer to the set of integer. So my function f of x is equal to, so f of x equal to x squared. So tell me about this function, is 1 to 1 or not? Yalla. From z to z. Is 1 to 1? Why is not 1 to 1? So if it's a 1 to 1, we have a deal before. If something is true, you should solve it generally. If it's not true, you should do what? Huh? Solve by not cases. You can say cases, but one case. Bring one example which is not true. And we rename this, thank you, we rename this what? As a counter example. Do you remember that? Good. So we should bring a counter example. So tell me, this function is 1 to 1 or not? No. So give me the example.
An example?
Yep.
For example, 1, according to the graph of x, is a parabolic. So positive side of x and negative side of x are both assigned to the positive side.
So give you one example.
Like
just that one number.
x1 and y1, and negative 1 and...
Exactly. Tamam. 1 and minus 1. So we have 1. If I want to show that it's not 1 to 1, it's better to bring one example. I say minus 1 not equal to 1, right? So we brought 2 different elements, but I can see but, I don't say then, it was not then, but f of 1, look, is equal to f of 1, f of minus 1. Am I right? Why? Because both cases equal to 1. But the definition say what? The definition say the image also shouldn't be equal. So in that case, we say is not 1 to 1. 1 to 1, or like that. 1 to 1. You got it, dear? Understood? Maybe that student bring 2 and minus 2. And he will get what? 4 and minus 4. You got it? Whatever you like, you should bring. How about if the other student bring 1 and 1? No, it's not working, right? The example is not good. So kindly be careful. Only I need to bring one example if it's not true. If it's true, solve it. You got it, dears? Good. Now, I'm going to change this example by if f is a function. So tell me about, is 1 to 1 or not? Is 1 to 1 or not? It is, right? Why? Because we are talking about just positive, so there is no negative. We took out the problem part. We neglect the problem part. Okay? Any question? Tamam? Good. So this is about how to play with the examples. How to understand. Tamam, of course you know f of x is equal to x plus 1. F of x equal to x plus 1, of course, is what? Or you can read like that. Of course, is 1 to 1, right? So tell me in calculus 1, cal 1, we test the graph. If you, for example, you know the graph. We test it by something. What was called? How do you know this function is 1 to 1 or not?
Horizontal line test.
Horizontal line test. She's right. If by horizontal line test, we test the graph is intersecting 2 points, we say is not 1 to 1, the other is 1 to 1. Good. Any question? Clear? Good. Read that one, is just for reading at home. Now we have an increasing and decreasing function, and also we have another two things here. We have increase strictly or just increased. What's the difference between strictly and the other? If we have a equality sign, is the strictly. If just we have a less or greater, we have a strictly. Means a strict, there's no way. Okay, what's the definition of them? Both definitions. So I'm going to write the definition for both of them. As you can see from here, we have what? For each xy less than y, then if x less than y, and for each xy, if x less than y, if we have something like that, and strictly decrease xy. Let me summarize it for you. If we bring two x and y, okay, from the domain, x and y from the domain of the function, we say for each x and y, well, it means that any one, you should select all of them. Okay, in the original, if I bring two numbers like that, one of them is greater than, like 1 and 2, 3 and 5, like that, minus 2 and 2. Then the function of them, if I got the function of them is less, we say what? We say that one is increase function. How about if the same, but is called decreasing function? Understood? So we have an increase and decrease. In calculus 1, we got this definition. Also in chapter 4, I think, we got the application of derivative. By first derivative, we recognize it. Now here, we have this two definition, which is easy for you. Okay. Now, I'm going to talk about the examples. We have f of x squared from r squared to, r positive to r positive. So we have function from r positive to r positive, and my function is what? X squared. So kindly tell me, is it increase or not? Increase? How? Why? Because it's positive first, and any numbers we bring it, any numbers, for example, 2 and square root of 2, right? You like 3 and 5. So we say generally, we say for each x in the domain and for each y also in the domain, if x less than y, of course, x squared is less than y squared. Am I right? No, we should show it. How we show that one? How we show this issue? Now I need to show, right? We want to show x squared less than y squared. Do not answer this question by example. Why? Because generally true. We say with the general true, you should show me. Prove it. How? What's a given? Given here? That one is given, right? So I'm going to use the given twice. I say x less than y, then xy, I'll get what? Am I right? Call that one as a first equation. Understood? Label it. Now I have x less than y. Am I right? Then x by y. I'll get what? Yy. Then xy will be what? Y squared. Now, x squared is less than xy. Am I right? At the same time, by the second question, xy is less than y squared. Am I right? So I got what? Am I right? Understood? So we show that x squared is less than. So means that this function is increased function. Clear one, yeah? What did I do? We are in our imagination, we say this is increasing, so show me your step. We say because we have the given is x less than y, so I'm going to multiply and I got that relation. I am going to change my question to like that. Tell me about is increase or not. I don't say decrease, I say increase or not. Wait. Yalla. Why?
It might be increased.
Might be decrease.
No.
Wait, one by one, sorry.
It's increased, but only excluding the two.
Yeah, same thing.
Same thing.
From the negative side of decreasing.
No, my question was what? My question is clear. Listen, Kaka. Huh? At the beginning, try to understand the question. I say this function is increase or not. I don't say the decrease or increase or something. Is increase or not?
We don't know.
You don't know. Who knows?
It's not positive or negative. But parabola and negative. You can't put it.
She said the same. My question is what? My question is not about show me the decrease and increase location. No. I say this function is increased generally. Is increased or not?
Yes, generally. Yes. Generally, no. No, generally, yes.
Who say no? Tell me the reason.
Because we cannot specify all the domains increasing.
I'm repeating my strategy at the beginning, at the first of the. When I ask generally, you say yes, you should prove it, like this example. When you say no, you are 100%, it's not right, it's not true. Give me an example, one example.
-1 is smaller than 0, but 1 is.
Tamam. Just one example. So your answer, if during the exam, you should answer like that. He say what? -1 is less than 0. He's right. -1 is less than. But what? F of -1, I'm going to check. Let me leave that one, right? Let me leave here, this box. F of 0. I am waiting to get what? To be less. But 1 is not less than. Come on, your answer finished. 2 lines. You should bring the counter example. Don't tell me by the paragraph. We don't need. I know you are right. All of you are right. But the answer should be like briefly like that. Give you the example, that's one. But if I say this is where is increase, then where is decrease? You say in the negative part is decrease, positive part from 0 or that one is decrease. You are right. How about if you don't like the Mir's example? I'm going to bring, right? -2 and 1, right? The same. I'll get what? 4. The same, and whatever you like. Yes. No. After the definition of increase, no say I will make it to positive or not. پێناسەی دووجا ئەوە نییە بڵێ ئەیکەم بە پۆزیتیڤیانە لەخێ بەوە نییە پێناسەکەی من پێناسی چی پێناسی ڕوو لە زیابوونە ئەڵێ ئەگەر دوو ئیلیمنتە هێنا خۆیان لە یەک بچووکتر بوون ئەبێ نەخشەکەشان لە یەک بچووکتر بێ یان نەتوانیت تۆ بڵێ لە گەورەتر بێ گەورەتر. You got it? And definition of increase is like that. I'm not talking about square is giving me the positive or not. No, my question is not like that. You got it? Tamam? Now you know how to answer? Good. So we have another definition. We have onto definition. Definition of onto. So we got the injective. What was one-to-one? Now surjective is onto. So what do you mean by onto? Here's the definition of onto. For each element in the other side. For each element in here, in B, for each, all of them, all. If you have 100, 100. If you have infinite, all of them, yeah? There exists Y. You should find at least one element here, at least, such that that one related to here. Okay? For example, in the previous example, here, tell me about this example. Is onto or not? Yes, each element has got what? Relation. None of them is left. If I have 4 here, or 0, so if I ask you, that one is onto? No, Kakaja. Okay? No. Why? Because 0, there is no relation to 0. But careful, both, 1-to-1 and onto is the properties that we give it to the function. If you don't have a function, you don't have a 1-to-1. Understood? If you don't have a function, we are not going to talk about 1-to-1 or no. No, when we have a function, then we are going to talk about 1-to-1. So that is function, yes, and that is 1-to-1, yes, but it's no, it's not 1-to-1 because of D and A, so it's not 1-to-1. So if I ask you onto, now yes, understood? So like that you can compare. And don't worry, we have actually the goods example here. I'm going back to the others. Look at this example, Kaka. Look, we have a 1-to-1, right? It's 1-to, but it's not onto. Why? Why is not onto? 2 is left. Tell me about the B, the part B. 1, 2, 3, 4, yes. All of them is what? Is 1-to-1. Is 1-to-1? No. Why? Because of A and D. Understood. So I'm going to the C, third example. So tell me about 1-to-1? Yes. Is onto? Also yes. So it's 1-to-1 and onto. How about that one? Not onto. Maybe also is not 1-to-1, right? Neither 1-to-1 nor onto. How about the E? Is not a function. So I'm not going to talk about 1-to-1 or onto. You got it, dears, by the how to recognize by the sign. Good. Yes. If a domain is empty, it's not a function.
If one of the points
It's not a function. Each element should have a sign. Yes. So now we have another thing. Was a breaking news. Good. Now we have what? Look at here, Look. We have 1, 2, 3 from this set to set, A to B. Okay. So tell me about is onto or not. So I'm going to check. We have a 1, 2, 3. Again 3. It's okay. So it's onto. But it's not 1-to-1. I don't care. Understood? Good. Now tell me about this this function. From integer to integer. Is onto or not? Onto, not 1-to-1. We know it's not 1-to-1. Is onto? Are you sure? Why? Actually, I don't know. I should write and think about it. F of x. Okay. Now, how's the graph? Am I right? It's something like that. I have 1, 2, 3, 1, 2, 3, and it's an integer, so we don't have any value between them. So if I put 1, I will get 1. If I put 2, I'll get 4, 3, 9. How about minus 1? 1. Minus 2? 4. Not minus 4, it's 4. Minus 3, again 9. So why is not onto?
0. Because of the 1 minus 1.
Because of the minus 1. Zeros also, we have it. 0, 0 square, we have it. But minus 1, minus 2, minus 3, they are not related. So, but in my domain, I have what? I have things. So, let me tell you a trick. We have what? We have a definition of onto another definition. Kaka. if codomain equal to the range, the function is what? Is onto. What do you mean by that? So tell me about the domain of here. Domain of this function. Not R. We have a 0, 1, 2, 3. Positive Z. Or you can say natural number. Am I right? You can say natural number or positive Z union 0. So let me buy union use union. So my range of this function is what? Is start from 0, 1, 2, because input is integer. That's why we don't have a R. Okay? It's not like a previous one. No, it's one by one, point by point. So you can recall as n, right? But codomain is equal to what? Z. So that one is equal to that one? No way. Understood? So I'm going to change this equation, Kaka. F of x from z positive to z positive. Even if I am not talking about z positive, from z to z positive. Tell me is onto or not?
So we say for the codomain, we say that equal to z?
The codomain of this function now.
Equal to z?
Yeah, it's the given. Here's the codomain. Okay. Tamam? Okay. Now tell me about this function. Is onto or not? The same. Take out. Yes?
0 to 1.
So if I put 0, for example, let me see. Yes, z positive. If I put 0, I don't get anything. If I put 1, I'll get 1. 2, 2, right? 3, 9. So, is onto?
This is on because each one is the z goes to the positive values of the z. That's how we know it's not always. We have one positive value, not one. Value only has you
Z. Yeah. Actually.
Because we have the minus.
So, is onto is not 1 to 1. Okay, give me 2. Let me give 2. In Z positive, you have 1, 2, 3, 4, right? So give me 2 in the output. Your output, let be 2. 2. We cannot include square root because we have a Z. I have 1. Let me see 0, 1, 2, 3, and minus 1, minus 2, and go. So each of them give me the Z positive? No, again is not what? It's not onto, right? Because we should cover it. We should cover the outside. So kindly be careful. Good. From R, the same example. Look, everything is changed. Yalla. It's onto right? And f of x the same. Why is onto? Because I can get all things here, right? All things here. If I put positive or negative here, I'll get from 0 to positive, tan union 0. Understood? Is 1 to 1? Is 1 to 1? No. If I wanna change it to 1 to 1, I'm going to change it like that. How many changes we did? We the same function, but with a variety things. You should think about it. It's not hard, but you should think about it. Okay, dears? Yes. Okay. Is 1 to 1 and on to. But we are here. Like that? Like this function, the dominant range? Yes. So I'm going to change that one. I have the same. Yes, is 1 to 1 and on to. But yes, on to 1 and on to. Ona usually 0 birinin için. Or you can say from R positive to R positive. Yes, is 1 to 1 on to. Why not? Tamam. Good. So this is about onto function, and we have a definition one-to-one correspondence. It's not a new for you. Kindly listen. It's not new. We have one-to-one and we have onto. If I combine both of them, it's called correspondence. One-to-one correspondence. One-to-one, or it's called bijective. Why bijective? You are in the computer. You know. What do you mean by bijective? Two bi. We need two things. Injective and surjective, so we have a bijective, right? So we have both of them. So the function, if it's at the same time one-to-one and onto, is called bijective. Understood here? Clear? Good. Now we talk about that one. And let me see. Last things before break, we have a identity function. طبعا identity function is just f of x is equal to x. If I give 1, I'll get 1, 2, 2, 3, 3, square root of 2, square root of 2, anything. At the same time, this function is 1-to-1 and on-to, okay? Depending on the situation that we have. Any question about here? Before we are going to the inverse, talking about the inverse? Yes? Good.